Hi there, and thank you so much for joining me today. So this video will start our discussion of Module 10, which is going to be focusing on two different inferential psychology tests. First, we're going to talk about a one-way chi-square test, and then we're going to talk about a two-way chi-square test. Okay? So before I get into the specifics of these particular statistical tests, I think we need to take a step back for a second and review some things. Okay, so the first item that we need to review is the distinction between descriptive statistics and inferential statistics, right? So descriptive statistics like the mean, median, and mode, and the various measures of variability that we talked about, like the standard deviation, for example, all of those things are considered descriptive statistics in that they allow us to use a single value to describe or explain an entire data set, right? So by looking at the mean, we can tell what the average value in our data set is, and by looking at the standard deviation, we can tell how far away a given value of x is from the sample mean on average. Okay, so we can gain a lot of information relatively quickly by calculating descriptive statistics. Okay? But we also have inferential statistics. And with inferential statistics, we're basically trying to use various quantitative indices to solve real-world problems. And specifically to make inferences rather, about a given population based on a sample, right? So a population is often a hypothetical parameter that we don't actually have access to. So we're trying to use the sample of participants that we do have access to tell us something about the population, right? And we've already talked a little bit about some inferential statistics. So for example, last week we went through the one sample t-test, right? So with the one sample t-test, our data is continuous, okay? So the data in our data set is continuous, meaning it's numerical. Right? So we have continuous data. And with the one sample t-test, we're trying to determine whether the data in our sample is different from a hypothesized population mean or not. Okay? So with the one sample t-test, we're trying to compare the data in our data set to a hypothesized population mean to see whether it's similar or different. Okay? So the one-way chi-square test is kind of similar to the one sample t-test, okay? But one critical difference is that when we talk about the one-way chi-square test, and by the way, chi-square is indicated by that funny little X there, so that's what that symbol notates, is the chi-square test. So when we use a one-way chi-square test, we have a single variable that we're looking at, and that variable is categorical. Okay, so remember, categorical data can either be nominal data or ordinal data. Okay, so with both nominal and ordinal data, we're not actually looking at quantitative measurements. Okay, but rather we have a single variable with levels. Okay, and we enter into SPSS, for example, arbitrary numbers that stand in for those different levels, right? So for example, we might have gender, and we would enter in 1 into SPSS perhaps to represent male and 2 to represent female. We could have political affiliation, which would have 3 different levels. We could enter 1 for Republican, 2 for Democrat, and 3 for independent perhaps. Okay? So essentially what we're asking when we conduct a one-way chi-square test is we're seeing if the percentages that we observe in our sample differ significantly from the percentages that we would expect to find in the population, right? So remember when we talk about descriptives with categorical variable, that's essentially what we're attempting to find out, right? So remember when we first did our descriptive statistics in SPSS and you had that giant census data set, and one of the questions I asked you was what percentage of the data set was female, what percentage of the data set was a particular religious affiliation, Jewish, Christian, etc. Typically when we talk about categorical variables, our sort of starting point with descriptive statistics is going to look at the different percentages of each level of the variable. Okay? So just like with the one-way t-test with continuous variables, we're comparing what we observed in our sample to what we expect to find in the population, right? So we would look at our data set, our sample data set, and see what percentages we have, and we would compare those to those we would expect to find in the population. Okay. So another way to think about the one-way chi-square test is to call it a goodness of fit test. So essentially what we're asking is how well does our sample fit in with the pattern of results we would expect to find in the population. Okay, so again, a one-way chi-square test is very similar, at least theoretically, to a one-sample t because we're measuring a single variable, right? We're looking at a single column in our SPSS data set, and we're comparing the frequencies or the percentages that we observe in our sample to predicted population values, okay? But the key difference is the type of variable that we're looking at. One sample t's are strictly for continuous or quantitative data, whereas the one-way chi-square test is looking at categorical variables. Okay, so let's say I have a deck of cards, right? So a standard deck of cards has 52 cards in it, and I decide that I want to take a sample of 20 cards from my deck of 52 cards, right? So in this example, right, obviously the full deck of cards is meant to represent the population, and the sample are the 20 cards that I select at random. Okay, so let's say we're trying to figure out how many of the cards we would expect to be read. Okay, well, let's say we would expect 50% of the cards to be red and 50% of the cards to be black. Right? Okay, so usually in a standard deck of cards, half are red and half are black. So we assume the same is true of our sample of cards, right? So our null hypothesis is that we will get an equal number of red and black cards. Okay, so in other words, we expect that the percentages of red and black cards in our sample will be equal to each other, right? So this is just how we would represent that in terms of notation, right? So we would expect the percentage of red cards to be equal to that of the percentage of black cards. Okay. However, there's always a possibility that maybe your professor is messing with you, or maybe you got a trick deck of cards, right? So maybe there isn't an equal percentage of red and black cards in the deck. Okay, so this would be your alternative or your research hypothesis, right? That there's not an equal number of red and black cards. Okay, so let's say I go ahead and draw my sample. So I draw 20 cards at random from my deck of 52 cards, and I get 8 black cards and 12 red cards. Okay, so remember what I expected to find was an equal number of each type of card, right? So that would be 10 red cards and 10 black cards, right? So 8 is different from 10 and 12 is different from 10, right? But is it different enough from 10 and 10 to be significantly different, right? So what a one-way chi-square test is going to tell us is if the percentages that we found in our sample or the observed percentages in our sample are significantly different from the percentages we expected to find. Okay? So essentially what we are asking when we conduct a chi-square test is the percentage of red cards significantly different from 50%? Okay, or do our results fit with what we would expect to find in a normal deck? Okay, so here is how you calculate the chi-square statistic. Okay, so I'm going to go through plenty of examples with you, but first I'm going to indicate what each of these letters mean. Okay, so whenever you see O, that means observed. Okay, so that's going to tell us the percentages in each level of the categorical variable that we got. Okay, so the percent of red cards and black cards that we observed in our sample. E stands for expected. So that's how many red or black cards did we expect to get, right? So that's the 50%. And then once we find the value for each of our groups, the observed and expected, then we're going to add them up. Okay, so for each group, you take the observed percentage minus the expected percentage, you square it, and you divide it by the expected percentage. And then you add those values up to get your chi-square value. Okay, so we got 8 black cards and 12 red cards, and we expected to have 10 of each of them. Okay, so we're going to take 8, which is our observed number of black cards, and we're going to subtract the expected value of 10. We're going to square it, and we're going to divide by our expected value, which is again 10. Okay, and then we're going to do the same thing for red cards. So we got in our sample 12 red cards. We subtract the expected value of 10, square it, and divide again by the expected value. Okay, so if we just plug in those values, we get a chi-square value of 0.80. Okay, so now that we know what our chi-square value is, what do we do next? Well, just like we did for the the one sample t-test, every single time we conduct an inferential test, we need to calculate our degrees of freedom, which is again the number of values in our sample that are free to vary. So if you need to review that, I would encourage you to go back to last week's videos and run through my hats example. Okay? So for the one-way chi-square test, the degrees of freedom is equal to the number of categories, okay, or the number of levels of our categorical variable, minus 1, okay? So for our deck of cards, there are two possible categories or levels, okay? We have red and black cards. Therefore, our degrees of freedom is going to be 2 minus 1, which is equal to 1, okay? And just like we did with the one sample t-test, we are going to set our alpha level to 0.05, right? And what that means is we would expect to get these results even if the null hypothesis were true, only 5% of the time. Okay, so we have our alpha level of 0.05 and our degrees of freedom value of 1. Okay, and if you were to look in your chi-square table with 1 degree of freedom and 0.05 level of significance, or alpha level, then you would get a critical value of 3.84. Okay, so now we need a decision rule, right? Just like we had for the one sample t, if your observed value for t, or your obtained t value is greater than the critical value, then you reject the null hypothesis, right? So again, if our chi-square value is greater than the critical value, we can reject the null hypothesis, okay? But here, our obtained chi-square value from our sample is 0.80, which is less than our critical value, so we retain the null hypothesis, okay? So how do you write these results in APA style? Okay, well, you're going to look for the same components that you were required to include in APA for the one sample t. So first we're going to indicate what type of test we conducted. So we would say a one-way chi-square test showed, okay? And you're also going to want to include relevant descriptive statistics, okay? So if it was a continuous variable, we would include things like the mean and the sample size and the standard deviation, right? But because it's a categorical variable, really the only descriptives we have are the percentages, okay? So we would say a one-way chi-square test showed that the observed percentages of red, okay, so 60% corresponds to the number of red cards that we got, 12 divided by 20, and 40% black cards, which again corresponds to the number of black cards we got divided by 20, okay? So we have that the observed percentages of red and black cards in our sample were not significantly different from the expected percentages of 50% each, okay? And then we would include our chi-square value, or our chi-square indicator there, notation, and we would put degrees of freedom in parentheses, report our obtained value, and indicate whether the observed p-value was greater or less than 0.05, right? So if we reject or if we retain the null hypothesis, it means that our p-value is greater than 0.05, okay? Okay, so just to recap the one-way chi-square, when you get ready to conduct this test, you're going to want to state your null hypothesis, okay? And you're going to want to indicate in your null hypothesis what your expected percentages are and your alternative hypothesis. And one thing I wanted to note is that in this particular problem, we expected 50% of each because we expected them to be equal, but that isn't always the case, right? So for example, if I administered a survey asking students what their political affiliation was, right? National surveys put college students at about 60% Democrat and 40% Republican. Okay, so those would be my expected percentages. Is 40% Republican and 60% Democrat, right? So it just depends on what your population consists of and what variable you're measuring. So your null hypothesis isn't always automatically going to be 50%. Okay. And then after you state your null and alternative hypotheses, you're going to determine the observed and expected values for each group. You're going to calculate your test statistic, or in this case, your chi-square statistic, using this formula. Okay, you're going to calculate your degrees of freedom, which is the number of categories or the number of levels in your categorical variable minus 1. And then you're going to use the chi-square distribution table to find the critical value for your degrees of freedom. Okay, and then you're going to compare your obtained chi-square value to the critical value that you found in the table and make a decision about whether to reject or retain the null hypothesis, right? So if your obtained chi-square value is bigger than the critical value, then you reject the null hypothesis, whereas if it's smaller, then you retain the null hypothesis. Okay, so let's go through one more example of how to do a one-way chi-square test. So let's suppose you are a store owner and you own an ice cream shop, and you are curious whether strawberry, chocolate, and vanilla are equally popular, or if one flavor is more popular than the other. Okay, so our null hypothesis, right, just like the previous example, is going to assert that they are equally popular, or that the observed percentages, okay, are the same for each level of the category, right? So just like the previous example, we had two levels. We had black and red, okay? So if they had equal numbers of cards, that would be 100% divided by 2, which equals 50%. In this case, we have 3 levels of our categorical variable of ice cream flavor. We have chocolate, vanilla, and strawberry. Okay, so our expected percentage, if they're all equal, is going to be 100 divided by 3, which is about 33% per flavor. Okay, and the alternative hypothesis is that the store doesn't sell equal amounts of each flavor. Okay. All right, so over 1 week, the store sells many ice cream cones, right? So this is the number of ice cream cones that the store owner sells in a single week, okay? So we have 216 vanilla cones, 261 chocolate, and 210 strawberry, right? So these are our observed frequencies, okay, for each of the flavors, okay? So now what we need to do is compare the number of ice cream cones for each of the flavors that we found in our sample over the course of the week to the frequencies that we expected, okay? So you see here we don't have percentages though, we have the number of cones. So what we need to figure out is how many cones of each flavor would we expect to sell if everything was equal, okay? So what we're going to do is we're going to add up all three of these values to get our total number of cones, and then we're going to divide by 3. Okay, so because our store owner sold 687 cones, right, that's just the sum total. If there was no difference between the 3 ice cream flavors, we would expect them all to be 687 divided by 3, or 229. Okay, so 229 for each of the flavors if everything was equal. Okay, so what we're trying to find now with our one-way chi-square test is whether either of these values in the first table are significantly different from the expected value of 229, right? So is 216 significantly different from 229? Is 261 significantly different from 229? Or is 210 significantly different from 229? Right? We know that they are different values from those that we expected, but are they significantly different? Okay. So now we have to calculate our chi-square value for this sample. Well, we're going to need all of the same components in our formula. We need our observed values, our expected values, and we need to subtract the observed minus the expected for each flavor, okay? And then we need to square it, and then we need to sum it up. Okay, so this is going to look kind of similar to the table that you made for calculating standard deviation. Okay, and it might look a little bit cumbersome, but it's much easier than you would expect, right? So let's start with the first column. That's just our observed values from our sample. So we can just copy both the observed and expected values from our previous slide. So we have 216, 261, 210 for our observed values. 229 is our expected value for all three groups, okay? And then if we subtract the expected value from the observed value, then we would get negative 13, right? If we did 216 minus 229, that's negative 13. If we did 261 minus 229, we would get 32. And then 210 minus 29 is negative 19, okay? And then we're going to square that difference. And then we're going to divide the squared difference by the expected value, okay? So we're basically doing everything that the formula calls for, okay, for all three groups. And then once we've done that, okay, we're just going to add up all the numbers in the last column. Okay, so 0.74 plus 4.47 plus 1.58 gives us our critical value of 6.79. Okay, so now that we have our obtained critical value, or excuse me, our obtained chi-square value, we now need to find our degrees of freedom. Okay, so unlike the previous example that had only 2 levels, red and black, in our current example we have 3 levels, vanilla, chocolate, and strawberry. Okay, so to calculate our degrees of freedom, we're going to do 3 minus 1, which is 2. Okay, so with a degrees of freedom of 2 and an alpha level of 0.05, the critical value table is going to tell us that the critical value is 5.99. Okay, and because our chi-square value is greater than our critical value of 5.99, we can reject the null hypothesis. Okay. And now we're ready to report our results in APA style. Okay. So again, a one-way chi-square test indicated that the percentages of vanilla, okay, chocolate, and strawberry ice cream cones were significantly different from each other. Okay. So again, to find the percentages for each category, okay, what you're going to do is you're going to divide the observed value, okay, by the total value. So you're going to divide, for example, 216 divided by 678, and that'll give you a 31.44. If you divide 261 by 678, that'll give you 37.99. And if you divide 210 by 678, you'll get 30.57. Okay? Again, so when you report your results in APA style, you're going to indicate the type of test you conducted, which is a one-way chi-square. You're going to include your descriptive statistics, which are categorical variables. Those are going to correspond to the percentages of each of the category levels. And you're going to indicate your conclusion. You're going to report your chi-squared statistic and the degrees of freedom, and you're going to indicate whether the p-value is greater than or less than 0.05. So again, if you retain the null hypothesis, the p-value is greater than 0.05. If you reject the null hypothesis, the p-value is less than 0.05. Okay? So certainly reach out if you have any questions at all. And for my next video, I will run through another example of one-way chi-squares for you, just so you can get some more practice. All right? So take care, and I look forward to seeing you in my next video.